Tool geometry. Cutting tool must possess a shape that is suited for the machining operation. One important way to classify the cutting tool is according to the machining process. Thus, we have a turning tools, cut-off tools, milling cutters,
To
drill
achieve the
bits,
highest levels of
reamers,
precision and
taps, and many
efficiency,
other cutting
a cutting
tools
tool's
that
shape
are
must be
named for the
meticulously
operation in
designed
which
to
they are
suit the
used,
specific machining
each with
operation
its
it
own
will perform.
geometry. In
One of
some
the key
cases,
ways
is
to
going to be
classify
quite
cutting tools
unique.
is by the process they are intended for. Turning tools, cut-off tools, milling cutters, drill bits, reamers, and taps are all examples of tools named after the operations they facilitate. Each has a distinctive geometry tailored to its unique function, underscoring the importance of their design for delivering optimal results in manufacturing or machining tasks.
Cutting tools can be divided into two categories. A single point tool, which is used for the turning, boring, shaping, and the planing. And we have the multiple cutting edges tools, which used for drilling, reaming, tapping, milling, broaching, and sewing. There are seven elements of the single point tool geometry, and that's what illustrated in the figure B. There are several ways for holding and presenting the single point tool, including the solid shank, which typical made of the high-speed steel, and also can be done as a braced cemented carbide insert, and finally as mechanically clamped insert for the carbide, the ceramics, and other very hard tool materials. Insert cutting tools are widely used in machining because they are economical and adaptable for many different types of machining operations, like the turning, the boring, the threading, the milling, and even the drilling. They are available in a variety of shapes and sizes for a variety of the cutting situations encountered in practice. Most multiple cutting edge tools are used in machining operations in which the tool is rotated. The primary example are the drilling and the milling. On the other hand, broaching and some sewing operations like the hack sewing and the band sewing use a multiple cutting edge tools that are operates with a linear motion. Other sewing operations like the circular sewing use rotating saw blades. Most common tools for the twist drill are for hole making. Usually, they are made of a high-speed steel. Shown below is a standard twist drill geometry. Rotation and feeding of the drill bit result in a relative motion between the cutting edges and the work material to form the chip. The cutting speed varies along the cutting edges as a function of the distance from the axis of rotation. The relative velocity of the drill point is zero, so no cutting takes place. Instead, a large thrust force is required to drive the drill forward into the hole. The chip removal represents the main problem we have with the twist drill operation. The flutes must provide a sufficient clearance to allow the chips to move from the bottom of the hole during the cutting, but the friction makes the matter worse. The delivery of the cutting fluid to drill points to reduce the friction and heat is difficult because the chips are moving in the opposite direction. To solve the problem, we can use alternative drills, like the straight flute. Straight flute drill using the indexable cemented carbide insert for a higher cutting speed. Also, the gun drill can be used for deep holes. It has a carbide cutting edge, a single straight flute, and a coolant hole running its entire length. Also, for large diameter holes, we can use a spade drill. It can go for the holes that have a diameter up to 152 millimeters. Classification of the milling cutters is closely associated with the milling operations. The major types of the milling cutters are as following. The plain milling cutters are cylindrical shaped with several rows of teeth. that are used for the peripheral or the slab milling. The cutting edges are usually oriented at a helix angle to reduce the impact of the entry into the work, and these cutters are called the helical milling cutters. The form milling cutters are peripheral milling cutters in which the cutting edges have a special profile that is to be imparted into the work. An important application is the gear making, in which the shape of the milling cutters is to cut the slot between the adjacent gear's teeth, and thereby leaving the geometry of the gear teeth. The face milling cutters are designed with the teeth that cut on both the periphery as well as the end of the cutter. The face milling cutters can be made of the high-speed steel, and that can be designed to use simulated carbide inserts. An end milling cutter looks like a drill bit, but a close inspection indicates that it's designed for primary cutting with its peripheral teeth rather than its ends. The end milling is designed with a square ends, ends with a ready, and the ball ends. The end mills can be used for the face milling, profile milling, and pocketing, also for cutting the slots, the engraving, face countering, and the die sinking. The approach consists of a series of distinct cutting teeth along its length. The feed is accomplished by the increased step between the successive teeth on the approach. This feeding action is unique among the machining operations because most operations accomplish the feedings by a relative feed motion that is carried out by either the tool or the work. The shape of the cut surface is determined by the contour of the cutting edges of the approach, particularly the final cutting edges. Owing to its complex geometry and the low speed used in the broaching, most of the approaches are made of the high-speed steel. But in approaching of certain cast irons, the cutting edges are cemented carbide inserts, either brazed or mechanically held in place for the broaching tool. The broaching is only traditional method of the machining process that can cut a non-circular hole or a pocket with a 90 degrees corners. The saw plates possess a certain common features, including the tooth form, the tooth spacing, and the tooth set. The tooth form is concerted with the geometry of each cutting tooth. The rake angle, the clearance angle, and tooth spacing are among the other features of the geometry. The tooth spacing is the distance between the adjacent teeth on the saw plates. This parameter determines the size of the teeth and the size of the gullet between the teeth. The gullet allows space for the formation of the chip by the adjacent cutting tooth. Different tooth forms are appropriate for the different work materials and cutting situations. Next is cutting fluids.